MC9S08MP16 8-bit MCU for brushless DC motor control by Freescale Semiconductor. Welcome to the training module on the MC9S08MP16. This training module introduces the features Peripheral interface, which is useful for brushless motor control interface. The S08MP16 is a low-cost 8-bit MCU that delivers safe, accurate, and inexpensive motor control for a wide speed range of industrial and automotive applications. An ideal entry-level solution for brushless DC motor applications, it features an 8-channel PWM Flextimer module providing hardware dead time insertion, analog comparators, programmable gain amplifier, and a 12-bit A to D converter with PWM hardware triggering. The MC9S08MP16 is a cost-effective 8-bit MCU that delivers smooth, efficient, sensorless, brushless DC motor control across a broad spectrum of industrial applications. This page discusses the block diagram of the S08MP16 device. It combines with a 50 MHz CPU, a range of serial communication interfaces, and 3 onboard digital to analog converters. Its peripherals are tailored specifically towards sensorless brushless DC motor control and include 2 16-bit flex timers, 3 high-speed analog comparators, 16-bit PWM module with emergency overcurrent shutdown protection, a programmable gain amplifier, an engine providing clock failure protection, and memory content validation for safety-critical applications such as IEC 60730. The MC9S08MP16 and MC9S08MP12 are members of the low-cost, high-performance HCSOA family of 8-bit microcontroller units. All MCUs in the family use the enhanced HCSOA core and are available with a variety of modules, memory sizes, memory types, and package types. The clock inputs to the module indicate the clocks that are used to drive the module function. All memory-mapped registers associated with the modules are clocked with bus clock. The IC supplies the clock sources. The fixed frequency clock is internally synchronized to the bus clock and must not exceed 1/2 of the bus clock frequency. In clock configurations where this requirement is not met, the modules operate at maximum frequency. ADC and PGA have min and max frequency requirements. Flash has frequency requirements for program and erase operations. The ADC can perform an analog to digital conversion on any of the software selectable channels. In 12-bit and 10-bit mode, the selected channel voltage is converted by a successive approximation algorithm into a 12-bit digital result. The bus clock to the ADC can be gated on and off using the ADC bit in SCGC2. This bit is set after any reset, which enables the bus clock to this module. The module is idle when a conversion has completed and another conversion has not been initiated. When idle, the module is in its lowest power state. The keyboard interrupt module provides up to 8 independently enabled interrupt sources. The MC9S08MP16 series has 3 KBI modules referred to as KBI1, KBI2, and KBI3. Each KBI module has up to 8 interrupt sources. The KBI input pins can be used to detect either falling edges or both falling edge and low-level interrupt requests. Inputs are also useful as extra external interrupt inputs. The KBI includes 3 register status, namely control register, enable register, and edge select register. Features of FCI module include full duplex standard non-return to 0 format, double buffer transmitter and receiver with separate enables, programmable baud rates, interrupt-driven or pulled operation, which involves transmit data register empty and transmission complete, receive data register full, receive overrun, parity error, framing error, and noise error, idle receive detect, active edge on receive pin, break detection support LIN, hardware parity generation and check-in, programmable 8-bit or 9-bit character length, receive wake up by idle line or address mark, optional 13-bit character generation or 11-bit break character detection, and finally selectable transmitter output polarity. The central element of the SPI is the SPI shift register. Data is written to the double buffer transmitter and gets transferred to the SPI shift register at the start of a data transfer. After shifting in a byte of data, the data is transferred into the double buffered receiver where it can be read. Pin multiplexing logic controls connect between MCU pins and SPI module. When the SPI is configured as a master, the clock output is routed to the SPS clock pin. The shift output is routed to MOSI and the shift input is routed to the MISO pin. When the SPI is configured as a slave, the SPS clock pin is routed to the clock input of the SPI. The shift output is routed to the MISO and the shift input is routed to the MOSI pin. The operating modes of the MC9S08MP16 series are described as follows. It has 4 modes of operation: run mode, active background mode, wait mode, and stop mode. Run mode is the normal operating mode for the device. This mode is selected upon the MCU exiting reset if the BKG, D, or MS pin is high. The active background mode functions are managed through the background debug controller in the HCS08 core. Wait mode is entered by executing a wait instruction. Upon execution of the wait instruction, the CPU enters a low power state in which it is not clocked. One of 2 stop modes, stop 2 or stop 3, is entered upon execution of a stop instruction when stop E bit in system option 1 register is set. In both stop modes, the bus and CPU clocks are halted. All MC9S08MP16 series MCUs have 2 FTM modules. FTM1 is a 2-channel timer, and FTM2 is a 6-channel timer. The FTM uses 1 input or output I/O pin channel. FTM X channel, where X is the FTM number and N is the channel number. The FTM shares its I/O pins with general purpose I/O port pins. FTM1 and FTM2 are designed to support clock rates up to 50 MHz. The central component of the FTM is the 16-bit counter with programmable initial and final values, and its counting can be up or down. During stop mode, all FTM input clocks are stopped, so the FTM is effectively disabled until clocks resume. The high-speed comparator can be used to compare 2 analog input voltages applied to PN and MN. The analog comparator output is high when the non-inverting input is greater than the inverting input, and is low when the non-inverting input is less than the inverting input. This signal can be selectively inverted by setting HSCMP XCR1 to 1. There are 3 main sub-blocks to the comparator module: the comparator itself, the window function, and the filter function. Although the name implies a DC motor, it is actually an AC motor. Concentrated coil windings on the stator work in conjunction with surface-mounted magnets on the rotor to generate a nearly uniform flux density in the air gap. This permits the stator coils to be driven by a constant DC voltage, which is simply switched from one stator coil to the next. This process must be electronically synchronized to the rotor angular position and result in an AC voltage waveform which resembles a trapezoidal shape. Since there are no brushes or commutators, the brushless DC motor does not exhibit the arcing problems associated with a brush DC motor. The Demo 9S08MP16 is a cost-effective demo platform for evaluating and developing with a Freescale MC9S08MP16. The Demo 9S08MP16 package includes a Demo 9S08MP16 demonstration board, Getting Started DVD, Getting Started with series of microcontrollers, USB A to B cable, Quick Start Guide, Freescale warranty card. Application development is quick and easy using P&E's embedded multi-link circuitry and the included software tools and examples. An optional BDM board is provided to allow the use of an external BDM interface such as P&E's Cyclone Pro Automated Programmer or USB Multi-Link. Supports software development for Freescale's 8-bit and 32-bit version 1 Coldfire MCU devices include a full-featured IDE with editor, C compiler, Flash programmer, assembler, linker, and source-level debugger. It also includes a processor expert graphical-based automatic C code generator for rapid application development.